The other place I see people make mistakes is parentheses in the wrong spot. If you just divided the radical by that as opposed to the negative 30 plus or minus the radical. So parentheses in the wrong spot, or forgetting to do the radical. Those are the most common places I see mistakes. All right, so I have two answers there. What do the two answers mean physically?
I guess that it reached 40 meters above at 1.96 seconds after it was launched, and then it goes above, and then it hits it again on the way back down at 4.16 seconds.
All right. So let's take now the next aspect of it. Let's use this fourth equation here to figure out how fast it was going. So we're trying to find VF squared is equal to 30 squared plus 2 times negative 9.8 times negative 40. First, tell me what VF squared is, and then VF. Is that right? Yeah. All right. And so VF.
.036.
0.0316.
Just .036.
036. All right. Units.
Meters per second.
All right. So let's take a look at some semantics here. I've got an answer of 41.036. Now, I've ignored a math aspect here. If x squared is equal to 4, what is x equal?
Plus or minus 2.
Yeah. But I don't put the minus sign here. Why not? Why is negative 41.036 actually not the correct solution physically? It comes down to what did we actually find? What does VF represent?
Velocity.
No.
Final. Fine.
You said time? It's not fun, it's not velocity. How do I know that it's not velocity here?
That's speed.
How do I know that's speed?
Oh, because it's squared.
Yeah, or there's no factor symbol over it. Yeah, it's squared in essence, does it? So what we're finding here is speed. The question I asked was how fast is it going? I didn't ask what the velocity was. Now, physically, I know that at 1.96 seconds, it's still going upwards, so the velocity would be positive, because we said up was positive. At 4.16 seconds, it should be going downwards, so the velocity would be negative. But the speed is positive, a positive number. All right, questions before we do the 40 below? Let's do 40 below. What changes over here?
Negative for the displacement.
Yeah. And why is it negative?
Because we said up is positive.
All right, so the only thing that's changing over here is this is now negative 40. So that becomes positive there, and everything else stays the same. Someone be kind enough, or more than one person, so we can get verification.
7.25
Seconds?
seconds, correct. That is for the,
Did we get a second on that?
it's for the second one. First one should be,
What's the, mathematically, what's the other answer? 7.25 seconds or?
-1.1.
Negative 1.1? That seems reasonable. Benjamin, you look like you're about to say something, like you're about to
I
correct
was
yourself.
surprised.
Why are you surprised?
I don't know, it just didn't seem right to me.
I don't think you divided, maybe.
I am expecting one to be negative and one to be positive.
1.3 if you want to add another.
113 or just 13?
1.13.
All right, we do have another way of checking our answers here, just to see if they're in link with each other. What is the average of these two times? And then what are going to be what's the average of those two times? And those?
See, I got something different than Benjamin. I got negative 7.2486 and positive 1.126.
Oh, you got negative this and positive that?
Yeah.
All right, so where would that have gotten thrown off? Did you do the negative on the bottom?
I didn't, no.
Okay, that would do it.
So flipped of positive 7.2486 and negative 1.126.
All right, so negative 1.126. Yeah, he had 3 there, and you had I think 4.8.
Yeah.
So been rounded in a different spot. On a test or quiz, either one is fine. So what's the average of the numbers?
Same.
All right, so we do have the same average in both cases here. What actually is that 3.06 seconds? That has a physical meaning besides the average of those two numbers.
The turnaround?
Yes, that's the peak. Because what's happening mathematically, and I'm going to clear this at this point. I don't remember what I did with anything. There we go. Is it is trying to solve a parabola. So if I have, I guess in essence, position versus time, it's going up. So at this point right here, the slope is 30 meters per second, comes up and goes around. So the correct answer would be that spot right there, where that is 40 meters above that. If we extend it backwards through time, that's the other answer right there. So this would be negative 1.113, and this would be the 7.25 seconds. Because the symmetry halfway in between them should be the peak. with 3.06 seconds. Or for the first one where we had answers of 1.96, so when we went 40 meters above it, so if that's 40 meters there, that would be 80 meters. And again, on the way up and on the way down, and that would be 1.96 seconds. 4.16 seconds. Questions? Then let's talk about due dates. All right, so chapter 2, we've done, pretty much done chapter 3 also, but we'll get into more detail on that one when we do chapter 4. There's the other one. So today is the 28th. Oh, we have no class on the 4th. All right, so I'd say let's do the quiz on chapter 2 on September 6th. And in terms of time management, well, one, Osama's ready for it, but in terms of time management, there are, I think, 7 problems that are assigned, and so I'm going to take two of those of that group of 7. If you wish to work them all out, and you have questions about whether you got the right answer or not, just you can always send me an email, and I think odd answers are in the back of the book. And Master Set 2, why don't we say Master Set to the end of the 8th? If you want to submit online, or if you want to hand it in person, get it to me on the 6th. But pardon?
8.
The 8th, September 8th. Master Set 2 is based on old test problems. So it's almost like forced studying. All right, questions? I'm gonna go grab a prop, then I'll be right back. I'm just gonna let the camera run. So.
Chapel Hill got the all clear 4 minutes ago.
Chapel Hill or UCP?
Chapel Hill.
Yeah.
1 wounded.
Was it just people fucking around again, or was it like intentional?
We don't know yet. Because earlier they released a suspect, but they didn't correspond with the shooting or anything, no information. We just got to release them. At least they got the all clear.
No. We're ready on the clamp. There we go. Would be easier over here. All right, so what this is gonna do, basically lock it in place like that. When you trip it, the bar here goes shooting off in that direction. And so if we have a ball that is on the end here, when it hopefully is slick enough that when the rod shoots this way, because of inertia, this should not really move that far, and it should just basically fall straight down as the rod gets ripped out from inside it. And then this ball will get shot out. So the question is, which will hit the ground first?
Either.
They'll explode on the way?
No, they're just gonna hit at the same time.
Okay.
So the other ball's gonna shoot out,
Yeah, this one's gonna be projected out that way, this one's gonna fall down.
it's straight, right, not sloped?
Yeah, this one should fall pretty straight down.
I meant the other one.
Oh, no, that one's gonna go in an arc.
Like, it's not gonna get shot downward in any way, really.
If I set it upright, it's gonna be shot horizontally and it's gonna arc.
Okay, but I think the one that goes straight down is gonna hit the ground first.
All right, so we got a straight down, we got a tie,
Tie.
tie,
Straight down.
straight down. All right, so we got 2 straight downs and 3 ties. Let's see if physics by democracy works. That seem level? Better or worse?
Yeah.
That's good. Sure.
Okay. All right. Here we go. Which hit first?
I'm gonna be honest, I couldn't see it.
Listen.
I think the straight down one hit first very slightly.
The other one went.
Oh, there it is.
Right.
Camouflage. All right. You can also listen for it. Here we go. 3, 2, 1. Not the intent. Oh. I see it. All right, 3rd time's the charm.
Just about the same.
You're saying that one fell hit first?
Yeah.
It seemed like the same to me.
Why, like, boom, 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 not like one boom?
Oh, they did bounce, so I don't know. All right, well, you would accept the fact that it was close.
Yeah, for sure.
Okay. The fact that this was moving that direction did not have a significant impact on it. Now, it is possible that one hit first if this is not perfectly level. However, the point of it is that they both fell at the same rate. The initial velocity, which is horizontal there, does not affect the rate at which the vertical velocity changes. Mythbusters did an episode where they looked at a bullet being shot and they dropped a bullet at the same time that the bullet from the gun leaves the barrel. Another one fell at the same time. And even with air resistance, amazingly how close they got.
Like they shot it.
Yep. They were in a big warehouse and they shot one horizontally, and as soon as it left the barrel, another bullet fell.
What kind of warehouse was this?
A big one.
Yeah.
But if you get HBO or Max, as it's now called, Mythbusters is available there.
And they hit the ground at the same time.
Yeah, I mean, there was a fraction of a second difference between them, a small fraction.
Crazy.
In high school, we had to do a math project, and one of the students did shooting a bullet and falling at the same time to see if they hit at the same time. But you can imagine what a high school student has access to was not able to come to any conclusion. So in essence, what we're dealing with here is that if ever I need to figure out how much time that one is in the air, the one that was shot that way, all I have to do is calculate how long does it take for something to fall the same distance. So we'll start out on the simple situation of I am just going to shoot something at, let's say, 50 meters per second, a little over 100 miles an hour. We'll do it from a height of 20 meters, and I want to know how far out does it land. So instead of setting this up exactly like we did before, we now basically are setting it up twice. Now there is a much longer, more formal process we can go through to justify it, and if you wish, I'll be glad to go do that, or just accept you're solving this as two problems, one vertical, one horizontal. So let's establish our convention. What are the positive directions? It's a two-dimensional problem, so we can't just get away with plus and minus per se. We have two different positive directions. That's what we're getting towards. Left, right, up, down. Which one do you want to make positive?
Right.
All right.
I guess down.
Okay.